Data and math. Data phase. What happens if we take a quadratic data column and start evaluating the same data starting at different offsets? What relationship do these functions have? Observations. If we arrange these functions in a matrix, the first column is constant. The second column is linear. And the third column is quadratic. So the first column is 3. Second, 2 times a, x plus b. And the third is 3x squared minus 9x plus 8. An important detail to notice is that this is the same as the original data column. Let's look at something a little bit more complicated. Here's a function, and let's build a phase matrix for it. We can see that the complexity of each column from the left to the right increases 1 degree until the final function in the rightmost column is the same as the initial data column. How are these functions related? The second function is related to the first in that it is actually its derivative. This is convenient. Unfortunately, the pattern does not hold. It turns out that the Pascal triangle allows us to extend the concept of derivative to multiple degrees. Not in the conventional sense where we recursively calculate a derivative until there's nothing left, but in a new way. The columns of the Pascal triangle are modulations that we can apply when taking a derivative, giving us a degreed derivative. Using a degreed derivative provides us with all the functions generated in a phase matrix. Here's a breakdown of how these derivative degrees work. The first derivative is 4, 3, 2, 1, 0, or exactly the derivative we learn in calculus. However, the second is 6, 3, 1, 0, 0, and the powers have been shifted. The next, 4, 1, 0, 0, 0, with another shift in the powers. And finally, 1, where all the powers have been shifted out of scope. What's next? This technology allows us to unify out-of-phase functions, where we can store just the index instead of a duplicate of the entire function. We can store functions in their most simple form. We can order coefficients for desired purposes, while only changing factors in reversible ways. Web demo and JavaScript API available at math.d8data.io.